Myself, I am Tony CJ, working as an assistant professor in the Department of Physics, Jyoti Engineering College, Cheruthuradi. Hi everybody, today we are going to discuss the semiconductor laser and applications of laser. So first part is semiconductor laser. Okay. It is a PN junction diode laser. Here N and P regions are heavily doped. Okay. Now what do you mean by doping? Doping is a process of adding some impurities to the p-type and n-type material so that its conductivity can be increased. Here we are using n and p-type material that are in solid state, hence it is a solid state laser. Here n and p regions are heavily doped. The basic principle behind semiconductor laser is, in forward bias condition, electron and hole recombine to produce the laser emission. Okay, here we are using forward bias. That means what do you mean by forward bias? A forward bias is we are connecting p-type region to the p terminal and n-type region to the negative terminal. This is a forward bias condition. So here electron and hole recombine to produce the laser emission. Now we will go in detail. First part is construction part. A heavily doped PN junction is fabricated in a single crystal of gallium arsenide. So as I already said, here we are using PN junction. Okay, so here the material used is gallium arsenide. Okay, here the active region consists of a depletion region in between p-type and n-type material of thickness 1 micrometer. So this is the p-type material and this is the n-type material. In between there is a depletion region. This depletion region can act as a active region. The width of the depletion region is about 1 micrometer. Okay, and now we will go to the next part. The top and bottom faces have metal coating to make electrical connection. So this is the top part and this is the bottom part. So this is made connection to the electrical connection, that is here p-type material that is connected to the positive terminal and n-type material that is connected to the negative terminal. So that is a forward bias condition. A pair of opposite faces is polished well to have optical cavity to enhance the intensity of laser. So these are the optically flat surface. This is the flat surface and highly polished, and this is also optically flat and polished face. And the laser output can be taken out from this region. So these two faces are polished surfaces. The other pair of faces is made rough to prevent the laser in that direction. So this front portion and this back portion, this is a rough surfaces. Okay, so these rough surfaces will prevent the laser in that particular direction. So the laser output can be taken only from the polished surfaces. Okay, for every laser we should have some pumping process. Here we are using the pumping process as forward bias. Okay, the method to achieve the population inversion is to forward bias the PN junction. Okay, now we will go to the working. So on n side free electrons exist in the conduction band and p side holes exist in the valence band. Okay, here n type the free electrons are the majority carriers and the p regions holes are the majority carriers. Okay, when PN junction is forward biased, that means p-type material that is connected to the p terminal and the n-type material that is connected to the negative terminal. That means hence it is a forward biased. The electrons and holes injected to the junction. Okay, so this is the p-type material. When it is a forward biased, the holes from the p-type that is go to the junction and the electrons in the n-type material that is go to the depletion region. Okay, that means the junction. Okay, now at low forward current, the spontaneous emission of photons and the junction act as an LED. Okay, now we are passing very small amount of current. Okay, so a spontaneous emission is happening. Okay, at low forward current, the photons are emitting. Now the junction will act as a LED. Okay. Now as the current is increased to a threshold value, the depletion region contains a large number of electrons in the conduction band. Okay. Hence the population inversion is achieved in the depletion region. If number of electrons in the conduction band is more comparing to valence band, then population inversion is achieved. Okay, that means the pumping process has been done. Okay, now the temperature at low temperatures and low current value, the spontaneous emission of photons are happening, and that means the junction will be act as an LED. Now we are going to increase the amount of current, that means the depletion region contains a larger number of electrons in the conduction band. Okay, so the conduction band will have the larger number of electrons. That means population inversion is achieved. That means the pumping process has been done. Now stimulated electron hole recombination. Okay, now the junction will have electron hole recombination. This will result in the laser emission. The intensity of the laser beam is increased by shuttling process the photons between the polished surface. Now this is a polished surface one, and this is a second polished surface. This laser beam can be taken out from the polished surface. If the shuttling process between these two polished surfaces is happening is more, then more amount of laser beam can be taken out. Finally, intense laser beam emerges through the polished surface. So only through the polished surfaces the laser beam can be taken out. Now the frequency of the laser beam mu is equal to delta E by H, or equal to EV divided by H cut. Okay, here V is the bias voltage that we are providing externally. Okay, and H is the Planck's constant. So this equation we need to study. Okay, now we will discuss some advantages. Okay, advantages of semiconductor laser. Easy to operate and handle. Okay, it's very the size is very small, so it's very easy to handle and low power consumption. Okay, the efficiency is more about 10%, and it can be increased by decreasing the temperature. Okay, the efficiency is more than 10%, and the efficiency can be increased by decreasing the temperature, and it is highly economical, compact, portable, and miniature size. It's a small size, so it is easily portable. It requires very low power to operate, and it requires only very small power. And some of the disadvantages is less monochromatic. Okay, this is a less monochromatic and a highly temperature sensitive. Okay, so it's a very temperature dependent device. So if the temperature is varying, it will affect the performance of the device. So we should take care the factor temperature. Now some of the applications. It is used to read the data that is enclosed in CD, DVD, laser disc, etc. Used for laser printing, laser fan machines, and laser pointers. Used in fiber optic communication. This chapter we will discuss in the next chapter. Used in measurement process. Used in barcode reading and UPC scanners. Okay, so that's it for the semiconductor laser. Now we will discuss some applications of the laser. Okay, we will mention some basic fundamental applications of laser. So laser has wide-ranging applications in the field of cutting metals, surgery, and light shows, CD, DVD, semiconductor manufacturing, then 3D laser. In many applications we have. Okay, in science, laws of interaction of atoms and molecules with the electromagnetic waves, then genetic research, then laser gyroscope to measure temperature, pressure, and electric field, magnetic field we are using. So laser gyroscopy has very important role in the case of applications. Spectrum analysis, separate isotopes, induced fusion. In industry, drilling, cutting, welding, trimming materials like diamonds, steel, glass. Then melting, evaporating, hardening, photolithography for printing the photos we are using. In medicine, bloodless and painless surgery. Okay, in for uh, for the case of surgery in eyes, we are using laser cutting tool, high degree sterilization, microsurgery, control bleeding, treatment of moles in faces, tumors of skin, destroy cancerous cells. In many fields we are using. In communication, optical fiber we are using bandwidth and a high directionality. Okay, the laser has the property of high monochromaticity and directionality. So in communication, that is a very important role in the laser. Large number of channels, free space communication. In military also we have many applications, range finders, target designators for missiles and bombers. In military we have many applications. Next, at home and office, CDs, disk drives, optical computers, barcode scanner, laser printer, then hologram, and to measure small distance with the help of interferometer. Okay. We have lots of applications of laser. Okay, thank you. That's it for the day. Thank you.